Now we are going to treat mean deviation in a measure of dispersion. We've treated range. That's we have three major ones. Three. We treated range already. Go to my video and watch range. Okay. Now we are treated the mean deviation. It is an absolute, or it is the absolute difference of all values in a data from the arithmetic mean. Absolute what? Difference. In the absolute difference in all data, all values or variables, if you like, put it variables or value, they are the same thing. In a given data, from the arithmetic mean, divided by the number, by the values. Okay, divided by the values, the number of values. Okay. So what it does is that it's simply, it's an arithmetic mean. Okay, of all the absolute variables from the mean. That's what it just indicates to us. Now, how do you get it? You just add. You can obtain this value by adding up all the absolute values of the deviation. Then you divide the answer by the number of value, value mean. That's the number of value mean. That's which means because deviation. YMD indicates what we call that is denoted with the word MD. That's mean deviation. MD. If you write M point, D point, that's mean deviation. Okay. Now, and the formula goes like this. Now, let's talk about the data. Now, now we have it this way. This is how it goes. Now you can see. Now we want to mean deviation. That's a measure of dispersion. Measures of dispersion. Now that's the heading. Now we've treated range. Now I'm going to treat mean deviation. Now this is the formula MD, as I said. MD. That's mean deviation, which is equals to sum of X means X there means values or the variables X minus mean deviation. This simply stands for mean deviation all over the numbers. Okay, where this stands for sum of all the differences. Okay, in deviation. Okay, now X is value or variable. I've made it clear. Variables. Okay. Now then this is mean, arithmetic mean. This arithmetic mean. Okay. This is sign note arithmetic mean, which you have seen already. Arithmetic mean. Arithmetic mean. Okay. Now YN is the number of variations. Now we are going to give an example here. You have just seen it. Now we are going to see. Let's make an example. Now example. Let's bring one example now. Example. To calculate the deviation of the following, let's calculate the deviation. Let's calculate the mean deviation of the following scores in an accounting test in a school in Adogo, the headquarters of Ajakuta local government. Okay, in Adogo, that's in Kogi State. Now the figures are, write it down: 4, 9, 16, 10, 20, 15. Now you must understand one thing. Okay. Now the difference between this one is that we are going to treat the one with frequency. Okay. Okay. Now if the one we are treating now, we are treating the one mean deviation without a frequency of data, where the frequency of data is not given. we are going to treat the next one. That where the frequency of data is given, that will be the next one. There we will go to draw table. But in this case, we are going to highlight and apply, okay, the formula and substitute. Then we get our own answer. Now I've just said it. Calculate. We are going to calculate the mean deviation of the following scores in an accounting test in a school in Adogo, the Ajakuta local government, the headquarters of Ajakuta local government. Okay, where is it situated in Adogo? Now, the figures are 14, 9, 16, 10, 20, 15, Now let's go there and solve the thing right now. Let's go there and solve it right now. Now, we have seen it. Now, this is the, I've just said it. These are the figures. Okay, so in case you didn't write it, 14, that's the figures. Or the numbers 9, 16, 10, 20, 15. Now, let's see what happened here. But you just have to stop the now mean deviation is equals to 14 plus 9 plus 16 plus 10 plus 20 plus 15 all over 6. All over 6 equals to. Now let me explain how I got this. So 84 all over 6, which is equals to 24. So mean deviation is equals to 24. Now, let me explain this. Our data here, we're told the figures given to us, mean deviation, which is 14. Now you are going to solve it like this. Based on our formula. Our formula says sum of variable or the values. Where are the values? See them. All of them, we sum them up over. That to get mean deviation. Okay? All the values. The formula says sum of, you have seen it. Go back and watch it. Sum of values minus mean deviation all over the total numbers. The total numbers, how do you get the total numbers? Listen. 1, 2, that's 9. 3, 4, 5, 6. So when you saw the sum of this mean deviation is the sum of the numbers minus the total distance all over the distance. That we first of all you sum it up first. That we are finding the mean deviation now. Sorry, we are looking for arithmetic mean. Sorry to say. Now, you first look for the arithmetic mean first, divided by 6. Then it gives you the total of 84 all over 6 is equal to 24. Okay, which means arithmetic mean is 24. Now we are going to apply our formula right now. How to get the whole thing? How to get now this is the first step. This is the first step. We have just treated the first step, looking for arithmetic mean. Okay, first step. This is the first step we have just treated. Okay. Now, the second step now Second step. What's second step? The second step is minus 14 plus 9 plus 9 minus 14 plus 16 plus 16. Now plus 16 plus 16 plus 16. Now that's plus 16, right? Okay. Plus 16. Then minus 14 20 minus 24. Sorry, 20 minus 14 minus 14 15 minus 14. Okay, then mean division minus mean division is equals to 18. Now, applying our formula right now. Applying our formula, we now come and see MD is equals to that X minus mean deviation all over the number, which is equals to 18 over 6, which is equals to now this is the application right now. Now the second step, this is the second step. Okay. Now you got what's our distance? You have 14. The first step is that you subtract that sum of the numbers, the values minus the mean deviation. What's the mean deviation? If you add all, if you see the calculation, if you multiply this by this, that if you cancel this by this, it gives you 14. You can see. Now this 14, this is 14. You do the calculation. I will explain this later. I want you to see it very well. This is 14. This is how it's done. 14 minus 14 plus 9. Where is that now? You see what the data we have just minus plus 9 slash 14 again plus 10. You're going to carry the figures one by one. Again minus 14. That 14 is still coming up. That 14 we are using. That's the number. Then minus 20 minus 14 plus 15 minus 14 is equal to the sum of values minus mean division is equal to 18. The total, if you do the calculation, which is now apply the mean division. Now what we did was arithmetic mean. That was what we found out. First, that gave us 24. Now we're going to find the mean division itself. It gives us sum of values or variables minus mean deviation all over the number. Then what is total? Is 18. What is the sum of the values minus mean deviation is 18. It gave us 18 all over 6 all over the number. If you count all the numbers, the values of the numbers there, 6. Okay, 6. Now which is equals to 3. That's our answer. That is our mean deviation. Okay, thank you very much. It's a very simple but very logical calculation. Thank you. Keep coming, keep asking questions, keep inviting students to the classes, ask questions, then we'll answer. Thank you.